Alright, here's the video for the end of LT7 notes. We did parts 1 and 2 before, and we still ran out of time, and so hopefully this video will be helpful. Alright, so just wanted to go over a few things here, okay? When we're talking about solving for inequalities, alright? So I'm gonna do this one. This is slide 12, alright? For this example, I'm going to subtract 7 first, okay? So this is going to be 2 is greater than or equal to 2/3 x. And one thing I want to remind you of here is, since we've got this fraction, we're going to multiply by the reciprocal, right? So that's going to be 3/2 on both sides. Okay. Now on this left-hand side, you end up with 3, right? And this is going to be greater than or equal to x, right? These cancel out like that. Okay. Now 3 is greater than or equal to x, or another way of saying that is x is less than or equal to 3. All right. So that's the inequality notation, right? X is less than or equal to 3. Okay. Now, when we do interval notation, sometimes it's helpful to draw a graph, right? And so if we have 0 and 3, right, we know it's going to be a filled in circle at 3 because it's less than or equal to, and then we're going to shade or draw an arrow to the left, right? Now for the interval notation, remember, the first number represents where does it begin, the second number represents where does it end, okay? So meaning the left-hand side, where does it begin, there kind of is no beginning, right? It would be negative infinity, okay? And then where does it end? It ends at 3. Remember, negative infinity always gets the parentheses, and 3, since there's a filled-in circle, that's going to be a bracket. All right. Okay, on slide 13, right? We've got x minus 7 over negative 2 is less than 5. So I'm going to multiply first by the denominator, right? So I'm going to multiply by negative 2. Multiplied by negative 2. So I have x minus 7, and on the right hand side I have negative 10. But because we multiplied by a negative, right, we multiplied by a negative 2, the inequality needs to switch. All right. So now we're going to add 7 plus 7, right? This is x is greater than negative 3. Okay. So x is greater than negative 3. So if I have negative 3, that's going to be an open circle. And I'm going to draw an arrow or shade to the right because it's greater than. Okay. Now for this one, for the interval notation, where does it begin? It begins at negative 3. Where does it end? It doesn't. It keeps going to the right. So that's going to be infinity. So negative 3 gets parentheses, and infinity gets parentheses. Alright, in slide 15, I'm going to look at this math team example. It says the math team is selling pie t-shirts for $8 each. They need to raise at least $500. I'm going to underline this. And they've already made $337.50. Okay, how many more shirts do they need to sell? So, we know that each shirt is $8. So that's going to be 8x or 8t, right? Plus, they've already made $337.50. Okay, and their goal is to raise at least $500, right? Now, when it says at least $500, that's the minimum, right? What they're saying is we want $500 at the smallest amount we're going to make, but we want more than that. So this expression 8x plus 337.50 is going to be greater than or equal to 500. It can equal 500, but that's the smallest amount we want, right? So that's why we're going to express it as greater than or equal to, okay? And then we would solve from here, and I'm going to have you do the rest, okay? Actually, on second thought, there's something I want to talk about with the answer here. So when we subtract 337.50 on both sides, okay, we get 8x is greater than or equal to, that's going to be 162.50, right? And then when we divide by 8, and if you do it on your calculator, what you end up with is you get 20.3125, okay? That doesn't make sense though, right? Because we're selling shirts, okay? And so if X represents the number of shirts, okay, you can't sell 20.3125 of a shirt, and so we actually need to round this up, right? So we're going to say X has to be greater than or equal to 21, all right? All right, on slide 16, I'm going to do the bottom example where we are practicing solving with variables on both sides. And so here I'm going to multiply by this 2. I'm going to distribute. So I've got 2x plus 4 is greater than or equal to 3x minus 1. Okay. I'm going to subtract the 3x to both sides here. Then I've got negative x plus 4 is greater than or equal to negative 1. And then I'm going to subtract 4. So that's negative x is greater than or equal to negative 5. And lastly, I need to divide by negative 1 because I need a positive x, right? And at this step, because I divided by a negative 1, I'm going to make sure that I switch the inequality sign, right? So x is less than or equal to 5, right? So that's the inequality notation. The interval notation, right? X is less than or equal to 5. Filled in circle and to the left. So that's going to be negative infinity, comma 5 with the bracket. All right, in slide 17, again, I'm going to do the bottom one. And mainly, I don't think I'm going to finish this, okay, but something I wanted to mention with this problem. So this is going to be 4x minus 8 minus 6x, and then less than or equal to negative 9 plus x. Because here what I want to talk about is you can combine like terms on the left-hand side, right? So when it's on the same side of an equal sign or an inequality like this, we can combine like terms. So that's going to be negative 2x minus 8 is less than or equal to negative 9 plus x. And then from here, it's like the previous example that we did. Okay, so I'm gonna leave it here. All right, let's look at this application problem in slide 18. It says you want to join a DVD rental club. Members pay $10 a month plus $1 for every DVD they rent. Non-members pay $3 for every DVD they rent. How many DVDs do you have to rent to make being a member worth the money? Right? Member worth the money means in the long run, you're paying less than a non-member, right? That's what makes it worth it, because you're going to end up paying less than a non-member, okay? So what I'm going to do is the cost of member, right, is going to be less than the cost of a non-member, all right? So that's key. So the cost of a member is expressed by, it says $10 a month plus $1 for every DVD they rent. So that's going to be 10 plus, and we're going to say 1D, let's say, right? 1 DVD, okay, is less than non-members pay $3 for every DVD they rent. So we're going to say 3D D. Okay, so there's my inequality statement. All right. In this next one here, we're looking at a gym membership, right? Same idea. Members pay, again, cost of member is going to be less than the cost of a non-member. Members of the gym pay $30 per month plus $10 for every visit to the personal trainer. Non-members pay $14 for every visit to the personal trainer. And so this is going to be $30 plus $10 per visit. So I'm going to say 10V, right? For every visit is less than $14 for every visit. So 14V. Okay. All right. Now, if you think about it, let's say if you just visit once, okay, it's actually cheaper to be a non-member, right? Because 14 times 1 would be 14, and then 30 plus 10 times 1 would actually be 40, okay? But what I'm talking about is in the long run, right? You're going to end up paying less when you are a member, okay? And then a couple last situations I wanted to look at here, all right? When we have all real numbers, right? When I solve this out, I'm going to distribute on the right-hand side, get 6x, oh, not this one. I don't want to do this problem. Sorry about that. This is the one. Okay, I'm going to distribute here, right? That's going to be 10 minus 8x is greater than or equal to 8 minus 8x, okay? On the right-hand side, I'm going to add 8x. So that cancels out. That's 0, right? This is 0. And what I'm left with is 10 is greater than or equal to 8. Okay? And then you ask, well, all right, there's no x, but is this a true statement? Right? Is 10 greater than or equal to 8? Yes, it is. Right? When you get a true statement, okay, that means all real numbers is your solutions. What that means is you can put in any number for x, and this inequality will always be a true statement. Okay, so I want you to think about that. Because this last example that I'm going to cover, what do you think it means for no solutions then? All right. So let's look at something like this one here. Okay. If I subtract 5x on both sides, well, 5x minus 5x is 0, right? So I have 3 is less than or equal to -1, right? Is this a true statement? Is 3 less than or equal to -1? No, this is false, right? Because 3 is greater than -1, all right? So when you get a false statement, all right, that means there are no solutions, okay? There's nothing you can put in for x where it'll make this a true statement, a true inequality, okay? So sometimes that happens. So if you need to rewind and, you know, especially look at these last two examples, I would highly encourage you to do so, as well as this last portion of LT7. All right, let me know if you have any questions, okay?